Now, sometimes when people learn about foiling, they then say, great, I can use foiling for every problem that's a multiplication problem. Unfortunately, that's not a true statement. So when you look at part C, the first thing you need to be aware of is that this is not a problem that we can FOIL. So let's figure out why we can't FOIL on this problem. If you look at the first polynomial, we have two terms. That's a binomial. But our second polynomial, that has three terms. So that's an example of a trinomial. If we have a binomial times a trinomial, we cannot FOIL this problem. So when can you FOIL? If you have a binomial times another binomial. Both polynomials have to be binomials in order to FOIL. So if foiling is not an option on this particular problem, we have to think about the other options we had a moment ago when we were looking at part A. In part A, option 1 was to think about the multiplication problem as a distribution problem. We can still do that in this world of multiplying binomials times trinomials. So what I'm going to do on this problem is say that I'm going to take my trinomial and distribute it through to the two terms in my binomial. So with that in mind then, I'm going to write down my first term from my first polynomial, 3x, and then I'm going to write down my entire trinomial, 4x squared minus x plus 5. Then I'm going to write down my second term from my binomial, positive 2, and then I'm going to multiply that times the entire trinomial, 4x squared minus x plus 5. Now that I have that, then, we are once again back to a problem similar to things we talked about the other day at the beginning of section 5.5. We have a monomial, 3x, times a trinomial. That's a distribution problem again. So I can distribute the 3x through to each one of those terms. So, okay, let's think about what that becomes then. 3x times 4x squared. Now, that might be something that you need to break up. So if you need to, break it up. Think about 3 times 4, that's going to be 12. And then x times x squared, that's x to the first times x squared. Add those exponents, that's going to be x to the third. And then we can continue. 3x times negative x. Positive times a negative is going to be a negative. 3 times 1 is 3. And then x to the first times x to the first is going to be x squared. And then distribute the 3x through to the 5, that's going to be 15x. Now that we have that then, we're going to go ahead and repeat this process for our second multiplication. I'm going to distribute this positive 2 through to each one of the three terms in my trinomial as well. So I have positive 2 times positive 4x squared, that's going to be a positive 8x squared. Positive 2 times negative x, that's going to be a negative 2x. And positive 2 times positive 5 is going to be a positive 10. So now, once again, what I need to do at the end of this problem is combine like terms. So 12x to the third, that's simply going to come down because we don't have any other x to the third terms. X squareds, though, we have two of those. So here's a negative 3x squared, here's a positive 8x squared. So those are like terms. They're going to come together as a positive 5x squared. Then for the x to the first, we have two of those as well. So there are two pieces, positive 15x and negative 2x. Those are going to come together as a positive 13x. And then finally, my constant term, I only have one of those, so he's just going to simply come down as well. So there's our final answer, 12x to the third plus 5x squared plus 13x plus 10. Now, as you look at this problem, there are three comments that I want to make at this point. So, comment number 1. As you look at this problem, I chose to come in and distribute the trinomial through to the two terms in the binomial. Is that the only way that you can think about this problem? The answer is no. So, if you looked at this problem and you thought, could we have approached this problem a little bit differently and started by distributing the binomial through to the three terms in the trinomial? The answer is yes. So if you want to come in and do this problem by distributing the binomial through to the three terms in the trinomial, that is a perfectly acceptable way of doing this problem as well. And you would get exactly the same final answer. Now, some of your terms along the way might be in slightly different orders, but when you get to the final answer and you write it in descending order, you should get exactly the same answer. So what I would suggest is that if this is of interest to you, try it and see that you will get exactly the same answer. The next comment that I want to make on this one is that what would you do if instead of having a binomial times a trinomial, you had a trinomial times a trinomial? What happens if we would have x squared minus 2x minus 3 times 4x squared minus x plus 5? Well, we could do the same kind of thing that we just did. So we could take this trinomial and distribute it through to the first polynomial. So I could take this trinomial and distribute it through to the 3 terms here, and I would have x squared times the trinomial 4x squared minus x plus 5, and then negative 2x times the entire trinomial, and then negative 3 times the entire trinomial. Or, if you would prefer, you could do just the opposite. Take the first trinomial and distribute it through to the 3 terms in the second trinomial. The other question is, what would have happened if I started, instead of having a trinomial times a trinomial, what would have happened if I had 3 binomials? What would have happened if I had 9 minus 2x times 7 minus 4x times x plus 3? Well, if you look at this problem, what I would suggest is that you think about it in terms of the order of operations. We have 3 multiplications here, so order of operations says that you would do the multiplications in the order that they would occur from left to right. So the first thing that I would do on this problem is multiply the 9 minus 2x times the 7 minus 4x. If you multiply a binomial times a binomial, we saw on the previous problem that frequently when you multiply a binomial times a binomial, you end up getting a trinomial. And then, once we had that, we would have a trinomial times a binomial. And that's very similar to what we have here in part C. So be aware that I've shown you some of these problems, but there are lots of different places we can start these problems and end up in essentially the same place. So if we had 3 different binomials, ultimately you would do the same kind of thing that we did here in C. Multiply the 2 binomials in front, get a trinomial, and then multiply that trinomial times the final binomial. And again, very similar to what we saw just a moment ago in part C.